I'm not doing Mazak here because here we go from this approach. General to specific. General to specific. सामान्य से विशिष्ट तक. So that's why JEE Physics can be done in 3 hours. Quite an ambitious one. I knew it is an ambitious one, but when I was preparing slides, it really looked ambitious. Without slides, I can just speak for 3 hours and I can, even less than 3 hours, I can finish it. But since this is an online platform where I'm not seeing you directly, slides are inevitable. So when I was preparing slides for this, I really thought it's an ambitious goal in 3 hours. But children, you have to be ambitious. If you know how to work towards that ambition, you have to be ambitious. Only then you'll do something. I told myself, because I keep telling that to every child every day in my classes. But let me make it very, very clear from the word go. See, I'm not joking. Because this has got so many parts, I want people to clearly separate different parts and store them. And I told you children, I'm not kidding. So I don't want you to even think that way. In fact, some of you, or most of you actually, students of course, not the others, some curious onlookers like parents or educators need not have to note anything, but students who are in 11th, who are in 10th, and who are droppers or the repeaters, you can actually make notes, because you might have done these things here and there, but I'm not sure whether you actually looked at the way I'm going to show you things now. All right. So let us be serious, especially the unacademy children who are coming to my classes for 11th section. This might look a little formidable to you in the sense many new things I'll be talking. But remember, later when we do these things, you'd say, yes, sir already told this. So, and every day I was talking about note making, which actually is the most important thing. Yes, I divided the whole 3 sessions. Today, tomorrow 10 to 11 in the morning, tomorrow 9 to 10 in the evening, in the night. All these things I made into acts and scenes so that we have clear-cut separation for what we are talking. Right, children? Yes, good evening, Nagajyoti. Kachalla Kannatali, yes, Abhishek Mishra, Yashaswini Sinde, Abhishek Mishra, Khaja, Anand Pranav. All right, children, Raksha Agarwal. I want you to have some kind of a notepad with you and keep making notes as well. Okay. This is a serious class, believe me. Serious class in the sense not a time pass class where you can just watch few things and forget them later. It's not even a class where you'll quit in the middle. Not only quit in the middle, you need to attend all the 3 sessions to really see the whole physics drama to be revealed properly, children. Right? But remember, let me make it very, very clear in the beginning. People get it out whether sir is going to do some important problems which might appear in IIT-JEE Advanced. Yes, but let me tell you, it is IIT-JEE Physics, not JEE Practice. Practice is voluminous, try to understand. My heading was JEE Physics. And of course, I fear not practice is important, but practice without the ideas behind them is useless. I like one quote by Bruce Lee very much. He says, I fear not the man who has practiced 10,000 kicks once, but I fear the man who has practiced one kick 10,000 times. One kick 10,000 times, don't misunderstand it. That I'll one particular problem I'll do 10 times. Here I changed it. One idea 10,000 times. Yes, this whole physics is idea based. Remember it. To do it in 3 hours or 4 hours probably is not a big deal, because physics itself is like that. Nobody could have claimed, or nobody would have told that I'll do it in chemistry and maths. Impossible. But physics is such an interconnected subject from the first chapter to the last chapter. So that's where, though it looked a little ambitious, I've taken up this. But remember, I'll be discussing IIT-JEE Advanced Physics here. In the sense, some 15 to 20% of the topics from the JEE mains will be not discussed here. For that, I'll make a separate special class. I'll do a separate special class later. It is JEE Physics, not JEE Physics practice, in the sense, not that we are going to do some thousands of questions in 3 hours or even hundreds of questions. 3 hours probably, if you plan it properly, 3 into 8, 24 good questions only one can do. So therefore, don't think it is just that problem practice right now. Though I'll be showing few examples here and there, it's not that one. And I'm limiting myself to the IIT advanced syllabus. There's a beautiful syllabus. They will not put that extra topics, semiconductors, communication, electromagnetic waves, for a good reason, because they'll do those topics anyway when they go to engineering. Try to understand. Since the whole of physics basics are there in the mechanics and electricity part of the 11th and 12th syllabus, they thought they should test the depth in the topic, not just the breadth of the topics. All right, children. Now, yes. Now look at this. Yes. Actually, many times, probably you might think, is it possible to discuss JEE Physics Advanced Physics also in 3 hours? Look, when do you finish the syllabus? Will there be enough time for their own practice? Many times, anxious parents keep asking me, and I tell my answer like this. I tell them it depends on the student. When I say it depends on the student, don't ever think that I'm being what you call harsh towards the students. I'm not saying that whether your student is good or bad. What I mean to say is whether the student requires a top-down or bottom-up approach. What am I trying, children? I'm justifying how you can finish the syllabus JEE Physics in 3 hours. When somebody says, can you finish syllabus? I can, because they'll ask, if you don't finish syllabus, where is the time for their practice? The people say. That means in their mind, in the package deals they get from the market forces, they think there's a fixed syllabus, fixed number of questions. Teachers somehow know the tricks of it to make it easy or whatever, and they give it to you. You'll later sit and just go on mugging up. A very, very simplified approach they have for themselves. It's not like that. Some children will evolve, emerge, whatever words you speak, if you follow with them the bottom-up approach. And somebody, of course, remember, if you're a real serious IIT-JEE advanced candidate, I always prefer top-down approach. That means you start from the ideas and go to the problems. That works wonders. It worked wonders with great many number of students with me. But that's a culture. Once that culture is there, it comes for various reasons. Once that culture is there, children, definitely the top-down approach is the best approach. But all won't be at that level. So we can go from bottom-up. When you go from bottom-up, it takes time. When you come top-down, it doesn't take time. Do you follow, children? So here, when I said JEE Physics can be done in 3 hours, I really mean to say I go from top-down. That means I'll start with the ideas. I'll start with not my ideas, the ideas given by the great scientists. Yes. To do this particular session, what is my motivation? Mary Prerana. What is it? Please have patience, children. Don't leave in the middle. You'll be missing something very, very interesting. Yes, my old students. My old students whom I taught with top-down approach, and my old students to whom I taught with bottom-up approach. Actually, I like the students who grew up with bottom-up approach. Top-down students are always slightly better in their endowments. They are slightly better in their endowments. But the bottom-up approach people, what I found, what inspiration I've got from them is they're high in attitude. They don't know much, but they're ready to work hard and reach their goal. For them, we need to have a particular, even see, the bottom-up approach is also very scientific, try to understand, though it's a little time consuming. So I had patience, they had patience, and really they did their job. So those students are my motivation. From the time I was teaching them, that all kinds of students, I had been very lucky enough to have taught the best and to have taught the last. So that made my understanding of the students' minds, how the mind works, how the mind learns sciences. Really, I understood because I had been lucky to have interacted with all kinds of students. So those students are my motivation to do something like this, because this method worked. The top-down approach worked with many students. Few students coming from other places, they did not have time to do things. So they were sitting with for 15 days, 20 days. So within 15, 20 days also, I could finish a good amount of syllabus in a proper way. So that's my motivation, children, to say that we can do JEE Advanced Physics in 3 hours. And another great person, look at this, IITJEE. This one, he's also my motivation for going for this top-down approach. What it means, I'll tell you next slide. But current students and the industry, these are this industry, of course, I cannot change. I can influence to some extent these current students. Current students, in the sense, their whole thinking is guided by what the market says. I cannot change the industry, I told you. But I can definitely influence the current students who think that straight away from the first class itself, I start doing IIT-JEE problems. That's a very brute force method. Bhaskar sir calls it brute force, like you take some large number of sums and go on without understanding, try to keep fixing like that. Such a brute method, that is, it doesn't work, believe me. But the smart method is this. Especially for physics, it works in a big way. So that I'll try now. And how Irido was my motivation, I'll tell you. This is the book. Even today, I tell many people. But of course, remember, even for these solutions are available. The moment you copy the solutions, mugged solutions, you don't do much. It's a great book in the sense, this is all collected problems from the Russian Olympiad schools by this person, Irido. Solutions were written for that. But every problem is a gem of a problem. Like, you can discuss that problem for 2 hours, analyze the problem for 2 hours. Many more Olympiad problems have come in. But remember, I always find the source of those problems there in this book called Irido. But how did it inspire me to go to a top-down approach is there by your side. As a student also, that means exactly when I was finishing my 11th, 12th only, after 1 or 2 years later, this book got published. And in some other books also, I used to see this thing, problem books. See, this is fundamental equation of dynamics. He said, Newton's laws, 1, 2, 3 formulas are there before every set of problems. I was thinking, what is this? Just 3 formulas is given. So as a student, I was really wondering, why these 3 formulas and then so many problems? How can 3 formulas give problems? Many people even here, even now might be thinking, just 3 formulas it gives and gives some tough problems. How to do? These are not three formulas. There are three fundamentals. Remember it. Put in mathematical form. F equals ma, and a normal, F normal is m dv mv square by r. F tangential is m dvt by dt, and an equation there. A generalized approach to problems, basically, and that is my motivation. Anytime, even today, when I ask students to try good problems, I'll tell them, write the mathematical summary. I'll say in my classes also, at the end of it, I'll give the mathematical summary. Remember, it's not mathematics, algebraic equations, believe me. They've got some lot of conceptual power behind them. To get to one kind of a formula like that, scientists worked for years, believe me. Okay, so this is also one motivation for me to do this kind of a program. Yes, today, what we do, what are the tools for our discussion? This deduction method, general to particular. That means we'll catch one basic, which is already there. We don't derive it today, we cannot. But the culture I want to instill in you people, that in physics there is one, the top formula or the root formula, whichever you want to say. I said top formula because from where you can write all smaller formulas. The basic, because people went on digging and found that there's a final thing. After that, there's nothing else. That's what you mean by the basic. Basic and elementary are different, children. People misunderstand. And many times when I start my lesson, generally we start in a proper way, in a proper way. Students say, sir, I want to know the basics of this, as if I'm starting from the higher level. From A we start. But that A, B, C, D is looking difficult for them because they confuse the basics with elementary things. Elementary means like 2 plus 2 is 4, things like that. So I'm not talking about elementary things here. Elementary things you know already. When you said basics or fundamentals or principles, they're something different, children. So here today, we'll go from general to particular. That means a general formula from where how to apply it for many physical situations. And every physical situation is going to be a numerical problem for us. Yes, my first approach is this. I'll go from general to particular. That is a main formula, which derivation of which we don't require to know, but we try to understand it by discussion. And then how that can be converted to many formulas, many problems. That's the main approach. Juxtaposition. That is putting similar things side by side. For example, those people who did second year and who are repeating, they know gravitation, electrostatics. We can put them side by side in terms of formulas. So this mechanism I'll use. These are all the techniques in literature, actually speaking, but they can be equally applied in every field. This is juxtaposition. One here, one there, or many like that, one after the other. So we've got so many things in physics which are similar. They're not exactly same. Try to understand. Not one sheep after another sheep, but one sheep and a similar looking sheep on the other side. Okay, so gravitation, electrostatics can be put side by side, and at one go you can do both the lessons. Some of the students whom I taught know already about this, but I'm today giving a name. We juxtapose things and make physics simple for us. Okay, and children, I told you first is general to particular, second thing juxtaposition, and then mind mapping. Yes, this generally we don't get time in the classes to do. Today I'll be doing that. That there will be hub and there will be many branches out of it. That's how the mind receives, it seems. That's how the mind makes connections, it seems. So the mind mapping also I'll be using today to make it clear, children. And analogy, this is very, very important. If juxtaposition is putting same thing side by side or similar thing side by side like I'm doing now, analogy is this one. It's a comparison where an idea or a thing is compared to another thing that is quite different from it. Second years and long-term students should be knowing that there are few things in physics like this. If you remember, mass M in mechanics is similar to inductance L in electromagnetic induction. They're completely different. Mass is different, L is different, but somehow they do similar work in their respective fields. That's what you mean by analogy. Okay, so I use generalization, I use juxtaposition, I use analogy, and I use mind mapping. And apart from those general techniques, we'll be using Newtonian physics. There's a book, Newtonian Mechanics by A.P. French. Very, very good book, actually speaking. Whenever I find time, I keep reading that. Here, apart from the techniques there, here we follow the Newtonian physics all throughout. Remember, all 11th and 12th physics, barring one or two lessons, geometrical optics, and one or two ideas like that, everything is Newtonian physics, based on F equals ma and torque equals I alpha. I want you people to look at the whole physics in terms of forces first. It makes your physics good. It keeps you good for the future when you go for higher studies. And this kind of thinking, looking at a microscopic object, F equals ma is for a particle, try to understand. And extending that to bigger objects, that is going from micro to macro, microcosm to macrocosm, is a beautiful scientific approach. Just this, it helps here, but later also it helps in your life. All right. Now, so Newtonian physics I'll be using mostly, and that is F equals ma and torque equals I alpha, along with this one. This, in the beginning itself, we have to be very, very clear about this. Generally, I've been hearing from students and even teachers sometimes, force causes motion. This statement is not a very good one. When they say force causes motion, they mean to say that the bodies are naturally at rest. For a small human existence, the surroundings look actually very, very formidable and dominant, in the sense, when I go and look outside, I cannot see the edges of the earth. So I'll feel I'm a small person and there is something very big world outside, right? So everything around us looks to be stationary. So the mind somehow got into that mood that everything will be naturally at rest. Force will apply and make it move. That's not correct. Because, those students who keep listening to me know that force and rest and motion are relative. It may be moving with a constant velocity, it may be at rest, but force changes that motion is the main idea. But okay, we cannot blame that you always think to be at rest. So let us give you a feeling of rest all the time in doing problems. What did I say? Let us give you a feeling of rest all the time when you do problems. You reverse and add. This is the mantra. Manish Behra was saying, sir, that's a mantra. I use the same word here. So this reverse and add is going to be a beautiful technique which we follow in the classes, though it has got a better physical meaning. So Newton's laws and this reversing and adding, because every time I want to feel to be at rest, reversing my velocity on myself and then adding it to the observed particle, or reversing the acceleration of mine and adding it to the other particles acceleration, I bring myself to be at rest as if I'm a frog in the well. The frog all the time says she or he is at rest only. I mean, that well is only the word. So let us manage with that. But that frog in the well feeling you can get if you reverse your reference frames, velocity, acceleration, and add it to the person, body to which you are going to apply laws of physics. Are you listening, children? These are all the main ideas. Look. When I tell my old student, I forgot to mention one thing. 18 years ago, there were some great students. One of them actually tragic. He died in a road accident in the US. I had to attend his memorial, of course, online once again. But when there used to be some special day in the US where they thank their teachers, I think. That boy, he mentioned three teachers, three professors, three teachers actually. One his guide, the other his IIT professor, and then me. What he mentioned, you see, it appears I told him some time ago one statement. See, Pratyush, if somebody is doing better than you, they know something which you don't know. I actually forgot that. He was alluding to this, that if you know the fundamentals, if you know how to generalize things, that will be smart. Okay. So that kind of students are my motivation children, because this method succeeded. Because all the time I was worrying, how can be so brute? Like, how can people remember so many things? How can people remember so many problems? How can people do so many problems? Nowadays, people are doing, even I am sometimes making them do, because it is very difficult for children to buy into this method. But remember, yes, that's the reason I was telling you, I cannot change your thinking of, you don't want to go to reference frames, all that. I still have no problem, children. But get this mantra, reverse and add. You come to a feeling of rest. In your own world, you will be there and apply the equations, all right, and solve problems. We have to be on time, children. I'll move ahead. Yes, Raj Prithvi, hi. Yes, Vaibhav, Hruday P. Vaibhav Singh. Okay, children, Santosh Verma, especially the second year students and the long-term students will have a great benefit of this immediately for the exam. The first years, the 11th students, of course, may find it a little difficult, but focus on the ideas I'm talking. It's a good habit to get into this kind of a science learning, believe me. Okay, now look at this. Here, I've given one boxcar. You may put wheels if you want, or I can say there's a reference frame fixed to some moving body. There's a person standing here. There's a person standing here. All right. And there's another person standing here. These two are the observers. Observer 1, observer 2. He is the observed body, this fellow. So let me say this bus is moving with 12 meters per second from his perspective. And from his perspective, let me say this fellow is moving with 2 meters per second. With his perspective, he is moving with 2 meters per second. So if you want to find out, this is 12 here, I've mentioned here. The bus is going with 12. With respect to him, he is going with 2. So with respect to this person, he goes with 12. That is 10 plus 2. But for him, how does it, there are two things. One is the bus is going with 10. With respect to him, he is going with 2. So with respect to him, we say 10 plus 2. But for the same fellow, when you go inside, you simply reverse your velocity 10 on yourself. And on this also 10. This 12 and 10 will make it this fellow's velocity 2 in this direction. That's what you mean. He feels to be at rest when he does that. His velocity means the bus's velocity. He will reverse and add it to the person here. So this 10 and 12 will give you this 2 here. So this reversing and adding is going to be a technique in doing problems as if you're standing at rest and doing it, as if you're facing an actual situation. Are you all listening, children? Uttej Kumar, yes. Please don't leave in the middle, because if you leave in the middle, you actually don't get the benefit of what I'm talking. Okay, Jnana Gaurav, Manish, Yashwant, Shreya, keep listening to me. Right. But every time, I told you top down means this, we go a little mathematical. Actually, mathematically oriented people will enjoy this in a big way. And it is important. When I said bottom up, I'll go from physical examples. If you go from physical examples, you cannot do it in 3 hours. But if you go from maths and give one example, you can do it in few hours. That's the whole idea. This diagram, many people must be knowing, but remember, this is one moving reference frame or moving body. This is a coordinate system fixed to the ground. So a body being is observed. This origin is this reference frame's position coordinate is this. And the person's position coordinate with respect to this is R relative, we call it. This is R of the person with respect to ground. Law of triangular vectors gives you this plus this is equal to this. Differentiate, you'll get the velocity of this person with respect to ground frame, which is velocity of the person relative to the moving frame and velocity of the moving frame. Differentiate it, you get acceleration relation. These are actually called Galilean transformation equations. We don't mention them in the class because people will worry, sir, you teach intermediate syllabus, why are you going to some relativity, all that? Somebody will mention Einstein suddenly without even knowing. See, Einstein and these persons, and the books are some classics books which people would like to mention but will never read. If you say that, you'll get some status, but it's difficult to read them. All the classics, many less people read. Believe me. That is something which people flaunt. Yeah, even they are in that club, but very less number of people read actually that. So people will be worried, sir, why are you talking this big things? It's not at all big. I'm not naming it as a Galilean transformation, but remember, I am not the person to have created this, right? But look, this is one most important technique which runs through whole of our physics lessons all the time. And then look at this, A relative. That means acceleration of a body with respect to this frame is accelerate the body from the ground frame plus minus of the acceleration of the moving frame. This is what you mean by, sir, I understood theory, but numerical is not solved. This is not a proper question, Rishi Prakash. If you understood theory, you will be able to solve problems, which means you have not understood theory. Theory is not writing. Theory is not writing. This statement is not correct. Of course, it's not that when you do the theory for the first time, you'll understand everything. Only when you apply to problems, wow, that's why the theory was there, you think. But you can never say that you'll start doing problems. That's meaningless. I told you already, like you practice a kick 1,000 times, but out of 1,000 times, what was the basis behind it? Only is one, you need to look at it. Okay. So don't say that you understand theory. If you understand theory, you've understood everything. Believe me, theory is not easy. Okay. Now, so this is plus minus AM. This is reversing and adding. So reversing adding gives velocity in still waters. Yes, Tanay, good. You remembered nice things, right? Yeah, but remember, if this velocity of the moving frame is constant, if it is not accelerating, A relative equals A with respect to ground frame. This will go away. Which one? This will go away. If this is constant, this will not be there. That means the acceleration you look from outside, from the ground, acceleration you look from the accelerating frame are 1 and same. Theory is used to solve the problems easily. Yes, that's correct. Isn't it? So theory have to be understood. They don't separate theory from problem, children. Theory is already there. To the extent possible, we'll try to understand it. If possible, we go from the first principles and derive them, then apply it to few problems. After applying, of course, you will understand it fully. That's for sure. I agree with it. Because you won't be knowing, unless you applied it, you won't be knowing that they are derived from the basic experiments. But you cannot say that only by doing problems I'll do it. That's not possible. Even if you do a problem, sometimes I do that approach. For people who learn something here and there, I can start a problem, but through the problem I can show physics. That is physics by example, we call. But ultimately, whether you do the problem first or theory first, the theory is ultimate. Believe me. Okay. Now, sir, Y3 class call title possible. Hey, sir, Y3 class. Theory is important because even if we do not remember the way we do question, if we know theory, we can reach this solution. That's correct. Yeah, we'll know it actually. Right. Now, what is the meaning of A relative being A with respect to ground frame? Say, for example, this box is going with a constant velocity. Remember, children, mechanics is the heart of the whole thing. blood flows from the mechanics lesson to every other branch of 11th and 12th physics. So today I'll try my best to do that, at least up energy conservation. Remaining thing tomorrow twice we'll take and connect up all the formulas in the whole lessons with a meaning. Now look at this, is going with a constant velocity. Some ball is dropped. So for this fellow inside, it falls with G. Even for this fellow, it falls with G. This is what we mean by saying that if the reference frame is not accelerating, the acceleration here and here for this person are one and same. Only when this accelerates, you get something called pseudo force, isn't it so? So from that transformation equation of accelerations, we get to this transformation equation of forces. Remember, this is the final thing. Believe me, in every physics problem, there is a basic, like this is called the basic. Basic is like you have an intuition. You need to have an intuition approach, children, intuitive approach. But intuitive approach has to be put into mathematical terms finally. So if at all you have a doubt about what is a pseudo force, for the linear motion, of course, this one. This is how you define a pseudo force. That is, all this comes because of the real forces. Real forces may be normal force, mg, tension, friction, force of buoyancy. Many things might act on a body and they give this net force. And this is simply mass of the body into reference frame's acceleration in the opposite direction. That's what we call a pseudo force. All good students do the things in a smart way. And doing smart in physics is going to this kind of a route. This kind of a route you should go. So you can deliberate over this for a while. Okay, this equation is there. Let me understand this pseudo force. From this equation, it seems this is the ultimate equation, but here I put it for the linear motion, basically. Okay. Now, sir, can diploma students write JEE? I think so. Just this is not the place to talk about. No, friction is pseudo. No, not at all. Friction is real force, children. Here I wrote friction, tension, weight, N, force of buoyancy, all that. Shyam Khasilwal, Pushpendra Kumar, Bhavesh Yadav, Nehal. Please listen to me carefully. Though I said 3 hours, if you're understanding and taking notes, I can extend it later for 1 more hour or 2 more hours. I can take other classes. But this kind of a summarization is going to be very, very important. Sir, you are looking like IIT Professor Priyanshu Agarwal. I'm all the time with IIT Professor Bhaskar, sir. So some culture rubbed in. Priyanshu. Okay then, right. And then look, here this is one equation. I want you to write the equations, even the Priyanshu children. Shreya Singh, Shreya Khanna, Tanai, Shivan, I mean, like all those students were attending, Manish Agarwal. Don't worry about how much you understood it. I just want that small notepad you can have and a summary. Because at the end of first year, you'll know. Are come on, the whole first year we did so many days, but finally it is only this much work you'll be jumping, I'm telling you. Do you understand? You'll be really jumping that time because, why did you take so many days for understanding this? Ultimately, it's only this much, no, you'll say. I did not been able to speak English like you. Are Priyanshu, you know, if you actually, I don't know better English than Bhaskar sir, believe me. If you have something to say in your stomach, language you'll find yourself. Don't worry. I don't know grammar, English grammar, I don't know properly. Of course, I've read many books. My English is only by reading books, not anything else. So, Priyanshu, in 2 years with me and Bhaskar sir, you'll also become an English professor. Don't worry. Okay. Right. Namaskar. Kushal Kaushal. Kushal. Priyanshu Agarwal, sir, I am glad to meet you. Thank you. I am equally glad to meet you, children. Language is not a problem. Definitely, Raj, isn't it? If you have got pain in the stomach, you will speak. That's all. Yes, sir. Right. Nain Jyoti. Yes, sir. Yes, correct. Right, children. But did you catch my point? This is the net force when you are sitting in an accelerating frame. That will be the sum of real forces plus pseudo forces. This is the idea I want. Okay, right, children. Now, this is one most important equation I've given. This might trouble 10th student.